Hey everybody. It looks like it's about time to start, so I'm going to go ahead and start. I figured since I was in Hawaii, I'd dress for the occasion, so I got a shirt. It's real pretty. If you're not in Hawaii, Hawaii's real pretty. Anyway, so let's go ahead and get this started. I'm going to be talking about facing the monolith. How many of you guys have built or worked on a monolithic application of some kind? Yeah, just about everybody. You've been there. So you know that pain, right? Well, that's what I'm going to talk about and how we solved it on one of the applications that I've worked on. So to start us off, I'm just going to introduce myself. I'm Charles Max Wood. I'm the lead developer at Intentional Excellence Productions. That's my own consulting company. So if you want to hire us to build you something, you just talk to me and we'll make that happen. I'm also the host of the Ruby Rogues podcast. I see James over there. He's also on the show. We have a good time every week talking about all kinds of interesting things. So if you haven't listened to that, you can go find it at rubyrogues.com. I also have a JavaScript show at javascriptjabber.com and a freelancing show at rubyfreelancers.com. So if you're interested in those, then feel free to check them out. I'm not going to go too deep into what the application did. I'm going to talk around some of the pieces that are there, but I don't want you to get neck deep in the details there. I put this up for another reason, and that is that if you've worked on a monolithic application, you know that you sometimes do wind up neck deep in shit. And so this is just, an illustration of how it feels to work on a monolithic application under some circumstances. So let's talk about this for a minute. We get this application. When you're starting to build it, it's just like, oh, well, we just want something that does this little thing over here, right? So you get something that's reasonably easy to take care of, and you're solving a problem. So your boss basically says, hey, tame this thing, And if you've ever had a cat, you never really tame it. But you kind of get the idea, right? Make it do something that it didn't do before, solve this problem. And so you start solving the problem. You get a real good feel for, okay, here's what it takes to do this, to do it right. In our case, we were building a lead generation platform. And what we were told was we wanted a system that would organize the leads. Sounds pretty simple, right? So then as things go on, what happens is they say, okay, well, now we need it to do something else. Well, cats don't bark. I'm sorry, they don't. But that's the specification. That's what the project needs to do now, okay? It needs to bark. So we start doing this genetic manipulation on our application to make it do something that it was never meant to do, right? Instead of working something else in that will handle barking for us. And before long, you wind up with this huge thing. And, you've got to teach it to do another trick. You've got another feature to add to this thing, right? And so your boss is basically saying, hey, tame this thing and make it work for us. And so you've got to keep track of all the different heads, and is it going to take your head off with its claws? And, it's just a major pain in the neck. So what we started with was an application that basically was this, right? It's a bucket. Put the leads in it. Actually, it's a little more like this. It's a bucket that we have to organize the leads in. So, maybe a file cabinet instead of a bucket. But, same thing, and databases do this organization thing pretty well. So not a big deal. Then you just build tables and make it look nice and stuff, right? So we also need to collect the leads. So, some system that will let you put leads in. Then that's fine. Maybe some external API, something like that. Not a big deal. But then, wait a minute, we've got these leads, and the way we make money is we sell them to the people that want them. So we need some way of taking the leads out and sending them off to whoever's going to pay them for us. And we need some websites where people can come in and enter their information so that we get the leads, so that they go into the system, so that we can send them off to the people that pay us to make money. And, it would be really nice for SEO if we had some kind of CMS, something that would draw people in so that they can come in. This is education lead gen, so, they come in and they start learning about some of the majors they can take and all this stuff, and then it'll help them find the right lead form, so then they can enter their information, so it can go into the system, so it can get sent. And we need some user administration because obviously not just anybody should be able to access these leads. And we need reporting so that we know how much money we're making. And we verify the leads through our call center. So we need a call center app that can go in and see these leads and verify them and make sure they're okay, because if we verify the leads, we get paid more for them because they're higher quality. You kind of get the picture. And so we started with something like this and, have this process around it, and we just end up with this mess. So I've kind of worked through some of these. This is basically the lead collection workflow where you have all of these things going on. And then the other workflow has to do with managing the leads and putting them in the right place. So your boss comes to you and says, add a new feature, put an addition on this thing. And what it boils down to is you've got to teach this guy to do a new trick, and you've got to do it without getting your head taken off. So you defang, you declaw, you do all these different things. It really feels like every feature you're adding is just not fun. And you're doing all of this stuff. You're shaving these yaks to get this feature in, okay? You got to shave enough yaks to get enough insulation to put the addition on the house, okay? And yak hair is high quality insulation. I just wanted to point that out in case you were wondering. So then they're like, well, here's your backlog. Here are a whole bunch of features that we want you to add in. And so you get this line of yaks that you've got to shave every time you add a new feature in. And for the most part, as I started writing this talk, I started to realize that a lot of this could be handled through cleaner code. So if your code is well organized and you don't have quite as much of this, but ultimately where we had so many systems doing so many different things, it made sense to split it up into an SOA, and we'll talk about that in a second. The other problem was that we had a lot of stuff coming in. And so eventually what would happen is our application would get angry, and it would grow so large that it would just tear the server apart, trying to get everything done. So it would just hang out and stop. And so SOA also solved the problem of being able to scale out. You can scale horizontally, but you can scale vertically as well just by scaling up the pieces that need more resources. So it does pay to split up the application. And I'm trying to illustrate to you maybe some of the differences between when you can just improve your code and when you can actually improve the, split it up and find some architecture that you can do to make it behave the way you need it to. So in any case, you've got this large, complex project. There are a lot of things doing a lot of different things, and they're all tied together, and so it's tightly coupled, and it's a real pain to keep all the concerns in your head and make it all work. So what we did is, as you see, we found different pieces that had different concerns. So then it was just a bunch of little apps that you could kind of keep your head around. In other words, the problem set looks more like this. So then it's just small problems to tame instead of this monster that you have to modify in order to get anything done. And so what we did is we literally went to the point where we found systems that had a narrow concern that we could pull out of the application and just make it work for us. And so everything above the line is front-facing, so customer-facing, and everything on the back is services that were generally more data management type things. And so then we start getting into some of the infrastructure questions. How do you make one application talk to another service? And how do you send requests for data? How do you send data to the back end? And things like that. Well, some of the things you're going to do are synchronous, okay? You're going to send something, you need the response back. Or you send something and you need to know that it did the job immediately, which may be a better answer for queuing and then some synchronous callback. But you kind of get the idea. You're going to have some things that are synchronous that you absolutely have to have a response from. Some of the other ones, you just kind of leave it a message and you're not so concerned with the outcome, or at least something else may be concerned with the outcome, but you don't need to worry about that. This was more along the lines of the writes. So writing data, writing leads to the lead store, managing users when we were writing that information. The validation happened up on the front end, and then from the back end, we just dropped it in and assumed it was saved and expected a synchronous callback if something failed. And so, you know, it was just an asynchronous system. And like I said, if you're worried about the outcome, then you can set up callbacks so you can keep track of what got done. The other thing that the callbacks do for you is that it allows you to add some redundancy to the system, and I'll just talk about that real quick. Basically, the idea is that if you have a callback, then what you can do is you can say, I've added these jobs to the queue and I don't know what their status is. And then when they get the callback, then they can mark them as done. And what this allows you to do is then if your queuing system fails for some reason, then you know what jobs to populate back into the system. And so it gives you that level of redundancy if you care. Otherwise, you just, you know, drop it in and assume it'll get done. And we're all pretty familiar with the job queue setup and the way that those work. So anyway, here's some code for HTTP. This is basically something where we read the lead from. So this is the path to get a lead. It's pretty standard. You can see it's just a path. Can you read it in the back? I just want to make sure. Yeah. So it's a standard Rails type route. So you have this path to the lead service. It calls into leads, it gets JSON back, and then you get the response by calling that, and that gives you your JSON object. And we were using JSON. We were using Sinatra on the back end for these services. So then what we do is we do all the stuff to send the lead off to the school. Because again, you know, our customers are schools or some kind of lead aggregator that represented a school. So in any case, we would say, here's the lead, here's the school that it should go to, and it would just do its thing. And I'm not going to bore you with that. You could also then do a synchronous call to reporting if that's what you wanted to do, and just send the reporting app the information. If it needed to be real time, this was a good way to do it because then you know you got the response and you knew it went in. And you knew it happened right away, as opposed to worrying about the queue backing up. So HTTP was really good for us for synchronous calls. If we needed the response before we could go ahead, then this is what we did. We could take immediate action based on what happened on that service. And if we needed information from another service, then we could put that in. So just to sum up what we're dealing with here. And in the organization, you can kind of see some of the places where this was called. I know that the arrows are kind of hard to follow here, but it kind of gives you an idea that authentication, which are the two double-ended arrows. So basically, it was a request to authenticate the user, and then it would send back an access token. And both the call center and the management app needed that. And I didn't talk about the management app, but the management app was the representation of the data for people to actually see what was in the system. So let's talk about queues. Now, when we did this was a few years ago. Resque really hadn't hit its stride, or at least we didn't know about it. And so we used Beanstalk, and that's why I put that up there. We used the Beanstalk queuing system, which is pretty simple. It allows you multiple queues on the same Beanstalk app, and you can kind of manage things that way. However, my example is Resque, and it's really just because Resque is really easy to manage. So you can see here that we get a lead request. So we just go to our lead class, we do request, it goes down to the leads where we stored the leads, gets the information back, builds us an object. If we know which school we're sending it to, then we just set that up. Otherwise, we go find the school that meets the criteria. So we had rules that would help us determine which school to send things to. We'd submit the lead to the school, and then we would report it. And this was more likely what we did with the reporting. The other example was just something that I could put up here and give you an idea of what we were doing with it. So down here, on the other end, we just had this kind of a setup here, so that when we created a new lead object, then we could just send it off to the school. So let me go through these points. I have a few other talking points that I want to go over, but first off, so it's asynchronous. If you don't need the response to keep moving, you do that. We used it for writing new data primarily, and any jobs that we had to do out of band. So like sending things off to the school was obviously done that way. If you need to take some immediate action on this, then it's usually better to turn off the queue or tuning the queue and then monitoring it. So in a lot of cases, you can figure out how you need to scale your queuing system and make sure that it's getting done in a timely manner. Because in a lot of cases, you don't just want to drop it on there and assume it's going to get done, and then if the queue gets backed up, then you're in trouble. So you do need to pay attention to the queue so that things are getting done in the time limit that you need them to. We used this. We used the HTTP on GET requests, and then anything else that sort of needed to be posted went through here. So anyway, here's how we used the API for this. You can see that some of the services that we're pushing things to on a queue are actually on the front end. So you have services both on the back end and on the front end that play into the way that the system works. Now, I had a little extra time when I initially prepared this, and I wanted to talk about another idea that we kind of had proposed to us on Ruby Rogues. And the guys at Square brought this up. They had kind of a feed. And so the idea was that you'd get the information on a feed, and then you would just work through the feed. And so basically you would start off with a marker. So you could, this is a controller from Rails, and so you could request everything that comes after that mark. So you could say, I need the feed starting here, is the way that I came up to implement this. And then you get all the leads, you render them to JSON, and that's your feed. And then you'd have a daemon on the other end that would request the feed, it would work through the feed, and you kind of get the picture. So feeds are asynchronous. One thing you need to keep in mind with feeds is that every time it processes something off of the feed, it should do the same thing, so you can keep a consistent state. But the nice thing is that as you work through this, you might have it event-driven, but the thing is then you can do a full replay, and it doesn't matter so much. Otherwise, you have to compensate for doing the same job twice. So then we get into front-end services, and I am going through this way faster than I rehearsed, so we might get done a little bit early. So front-end services basically are everything above this line, okay? And so some parts kind of straddle the line. For example, the piece that gives us the web pages that collect the leads, it actually has a storage mechanism for the schools so that it knows which schools or which aggregators correspond to which forms. You can kind of also see things like the call center and stuff like that. Now I want to point out that we do have a service here in the users, and we actually built our own system that would take authentication requests and authorization requests and send back a key that was stored in the service or in the session of the front end service, and then would allow access to the rest of the system and could be verified against that service. But this is something that we could have moved to the front end. And the nice thing about doing front end services, so you have the back end pieces that are all broken apart and the front end pieces that are all broken apart, is that if you have a system that can act on the front end as this piece that we have here, then we can make it do what we want it to do. So we could have set up OAuth, is what I'm saying. So we could have moved the user's piece to the front end and then made it so that verification could have been done through an OAuth service instead of building our own. Another thing that we could have done with CMS is we could have used something like Refinery or Radiant or something. We had some pretty peculiar needs, so I don't know if it would have fit. But keeping in mind that there may already be solutions for some part of this, it makes a lot of sense. And in some cases, what you may wind up doing is either putting things in through Rack as middleware or through Rails in Rails engines or things like that, and really getting a good idea of this other responsibility, this piece of the app will handle for you. I do have a few notes that I want to share as well. One is on a response like this, you don't have to send all of the leads information back. You only have to send the parts of information back that this particular application is interested in. So you can make general purpose API endpoints, or you can make specific ones, and those ones will just cover the needs of whatever's calling in. Another note is that where you see leads here, basically the leads are in the top example and the bottom example, in the daemon and on the Rails app. Those are two different classes. And so you can more narrowly focus that lead class so that it only does the job that is needed in order to do these different pieces. So to store leads and manage leads with Active Record, and then on the bottom, the lead may just have enough information to get it sent to whoever needs to handle it, or to be managed through the worker. So let's talk about naming services here for a minute. One of my favorite ways is just to give it its own domain, and then you just know where to go. You can also do subdomains. You just set up some DNS, and then you know where to go. So it's leads.myapp.com or schools.myapp.com, and then you can just call in. I like having them named as opposed to some of the other options, just because then you know which one it is. So you don't have to remember IP addresses or anything crazy like that. You can put it on paths, and this is more of a middleware approach. Rack mount, the rack mount gem does a good job of this. It gives you some flexibility in this if you're using Sinatra, or you can just build it in as middleware in a Rails app. If you know the name of the server that it's running on, then this will work okay. But if it grows beyond one server, then you have to start doing load balancing and things like that, and it can get kind of complicated. IP address isn't my favorite because it's too generic, and you have to generally hard code it in or put some configuration file in or something like that, and it's just not as clean. For security, there are a lot of options as well. I talk about these. I did a webinar or online training on building JSON APIs, and there are a lot of options for security, and I'll talk through these really briefly. I think SSL is something that y'all understand. You have a certificate that, you get the information, you do a handshake, you encrypt the data, the other end has a certificate, knows how to decrypt it, and all that stuff. We're all fairly familiar with that. You can add it into Sinatra, you can add it into Rails, you can build it in, you don't really have to think much about it. You can also do encryption through a shared key. This is how SSH does it. And basically you can encrypt the data with your private key, and then you can decrypt it on the other end with the public key, and there's a lot of handshaking and stuff that goes on there as well. You can do some kind of server registration. So basically you set something up so that your server can prove that it has the authority to make calls to the system. And then from then on, since it's registered, it doesn't have to authorize or authenticate anymore. It just, does what it does. You can also have it get an API key, and then it passes the API key every time. You can also have a general API key that you just build in. You can do IP address whitelisting, so you can whitelist an entire subnet. If you've done much with the host.allow file, you kind of get an idea there. You can set up firewalls and just general authentication authorization stuff. A lot of these options are really good. It just depends on what your needs are and what you want to go over as far as that goes. So if you have any questions about those, I can answer some of those questions here in a minute. But this is the link to the online training I did for building JSON APIs, and that'll give you a really good idea of some of the things that you can do, some of the concerns that you might have in building out an API that you can use in a service like this to make it work. And this went a whole lot faster than I thought it would, so I'm at the end of my slides. If you have any questions, I'm happy to answer them. Otherwise, there are a few other things that I didn't put in the slides because I didn't think I'd have time that I can talk about. So,
for security, what were you doing for Beanstalk?
For Beanstalk, yes. We really didn't do a whole lot with security on Beanstalk, to be honest. We could have encrypted the messages when they went in, but
how did you know that something wasn't dumping messages in that it wasn't supposed to?
We didn't, to be honest, we didn't set up any security around Beanstalk.
Looks like when you did one web page, it might cause several other requests after talking to your other services.
Mm-hmm.
Have you a performance bottleneck when you want to have requests?
not really. He asked if when you do a request, I always forget that, the microphones don't pick this up, so. Anyway, so he asked if doing a request into one service, since it may call out to other services, cause performance problems among the other systems. Not really. Generally, the overhead of sending requests to the other systems wasn't the bottleneck. It was actually doing the job that it was supposed to do. And so what would bog it down more is that you're working through a job as opposed to pushing that out there. And it was much easier to maintain. We save way more effort and money in maintenance than it probably cost us in disseminating this knowledge across multiple services. And yeah, we only had one or two services that really got bogged down, and most of those were actually front-facing services. The back-end services were really, really fast. So, no, I would say no, not really. So he asked if we did anything to keep our models in sync between different applications. There were a few things that we did. One of the big ones was that we set up our own gems repository. This was back before Bundler, so we just install them ourselves. And so the gems managed the API connections. So if you had a front-end service, here, let me back up. So if you had a front-end service like, say, the call center, that needed to talk to the lead services, then we just built a gem around that. And so since the call center service and the reporting service and the management service all depended on the same connection to the lead center, we at least had a basis that was common between those, and when we updated the app, we would update the gem according to the dependencies that we built into that. So they might be on different gem versions, but ultimately the overall core was generally the same.
Yeah, related to that question, that assumes that you share code between different apps.
Yes.
Actually, when we're doing at Travis, we have like 6 apps, code from probably 30 repositories. So my question is, our code, since we don't upfront know which projects we're going to load into what programs. Our code is written in a manner from the naming that you could load all code from all applications into the same object space, which then means that our namespacing gets quite out of hand. So we have sometimes like 4 levels of nested namespacing. Did you face that issue, and what are you doing? Are you?
Right. So the question basically is, if you're pulling in multiple gems to allow you access to these different services, then you wind up with different classes that start to fill up the namespace in the global context. And so he's asking, basically, if we ran into that problem and did we wind up namespacing. And yeah, we ran into it pretty early, because under certain circumstances, sometimes we would have to have a different concept of 1 or 2 objects in different systems. And so what we would wind up doing is we would namespace these, and then we would have some overarching class, like if we had the lead services lead class that basically said, here's how you attach to leads and things like that. And then we had to have some other concept of lead outside of that did something else or did something more, then what we would do is we would basically treat that lead service class, we would namespace that under the lead services namespace, and then we would just reference that in our lead class. And so our lead class, our main lead class, may actually have like a related object that's of the lead class out of the lead services that was the persistence layer effectively. And so then we could pass that up and pass it down, and then we would just make the API seamless within our outer application and make that kind of hang together in a good way. It's easier to illustrate with a code sample, and I don't have one that I can just show you because I don't work for that company anymore. But I think you kind of get the idea. Is that clear enough, or? Okay.
So with a monolith, it's really easy to set up an end-to-end test, and a lot of the testing frameworks that people use with Rails make that convenient. But when you break it out into different services, you might need to integrate between two or more separately running applications. When you broke out this app, did you have any testing pain, and how do you approach?
So what you're asking is, since we've broken this up into many applications, if we had to test something that had to work through multiple applications to make it work effectively, you want to know if we had any pain testing that. And as far as acceptance testing goes, because I mean integration points, testing that is pretty straightforward. Does it talk to the right thing on the other end and get a good response? And so you can test the boundaries, and that's pretty clear. But if you have a full workflow where basically it's, the lead comes in through the CMS, it enters the lead goes through into the lead store and then gets passed out to the system that sends it out, that's a whole workflow that you want to make seamless and want to make sure it works. And so you have an acceptance test that more or less covers that. Now you can break that up a bit, and a lot of your integration tests will cover that. But yeah, sometimes it was painful, and the real pain in that kind of testing was basically setting up a fully blown system somewhere where we could then throw data at it and see if it did what it was supposed to do. And so then you start using frameworks like Selenium, or I'm trying to think of what some of the other ones are, but basically you have all the services running so that it just drops in and works through that system. I'm working on another client right now that has a fairly distributed setup, and we're passing through queues that are in Redis. It's not Resque, it's something else. But we're using all these different protocols and things that again pass through all these different systems. And so in order to make it all work, you have to stand up all the extra services that make everything talk to each other, and then make it work and drop down. But like I said, the main pain is getting that set up. And so if you have a good deployment process, it makes this a whole lot easier. And then you just have the test system that runs once a day or whatever, because these tests are going to take a lot longer than your smaller test suite. And you just push the data through and make sure that at every stage the right things are happening. And so it takes a little bit more instrumentation, which is kind of painful. And like I said, that setup is really what's painful. Especially if you're trying to set that setup up on virtual machines or something on your own box so that you can see it there. And so in a lot of cases, it's much easier to set up some kind of staging or testing that everyone can kind of access and look at, and then you can just work through it there. And then it's also set up for the acceptance tests that run every day or so.
Any other questions?
Expand on the last question. So you said it's very easy to test endpoint into small services. How do you usually do that? You make some fake service, test environment, or you literally do apps and
So the question is I said that it was relatively easy to set up tests, the integration test between, something that calls the endpoint and the endpoint. So we approached that a lot like the acceptance test, where we would stand up a service and then make calls against it. In some cases, we actually just, we could also just test it with Capybara and just make sure that the endpoint worked. And then the integration test was on the consumer library that basically said, it can make the end run with a live service and it still works. And so in some cases we would set that up in kind of isolation. That's much easier to set up on your own little development box, because then you can just run that library on your system and then have it hit the service also on your system. And generally that would work pretty well to do the integration tests. And then when we ran them in an automated fashion, a lot of times we would actually just use the endpoint in the setup for the acceptance tests, because it was already running. And then we just had a good way of clearing that before we ran, a huge suite or another suite, so that we could get consistent results and make sure that, what we were seeing was what we were expecting.
Any other questions?
What did you end up using for authentication? Just send a password like over an SSL connection, or did you encrypt it?
If that's a good question. I have to mention before I tell you this, because it really wasn't best practice, but this was also like 4 or 5 years ago. We were using, I think we had auth logic on our user service, and then we were just sending the username and password over an SSL encrypted connection in clear. And then we did all the stuff to make sure that they weren't being logged and stuff, and they were hashed in the database, but we were sending password data straight across. And I do like the approach, now that you mention it, of hashing the password on the front end and then verifying it. But at the same time, I mean, what the concern there is that it gets intercepted in a way that somebody can get the information out. And so whether you're passing a password or a password hash, the only difference is that the password hash is only good on the service, where the password is good on the front end system. So if you're getting intercepted, you're probably giving away authentication keys anyway. But that's what we did. And there are probably better ways of doing that. Any other questions?
I thought he was asking a different question, so I'll rephrase what I thought he was asking.
Okay.
You have a back-end service, and you have a front-end service, and your front-end service makes API calls to your back-end service. How do you ensure that that's the only thing calling your back? Like, it's not somebody else calling your back-end service. What mechanism did you use? Is it like only that IP is allowed to call me, and you have like a rule in your web server, or do you have like?
So initially, when we set this up, it was only running on one server, and then as things grew, we moved them out. And what we could do at that point is, we just had a whitelist of IP addresses. It got to the point where we whitelisted the subnet that we were on. And so it was like, this fraction of this subnet. And again, this is much easier to kind of show if you can put it up there, but basically you just say, look, these 16 IP addresses are okay because we own that whole block, and then everything else is fine. I think if we had grown to the point where we were distributing it more across multiple data centers and things like that, we would have gotten to the point where we would have put some kind of strictures in place where it was like public-private key authentication or something like that, where the whole connection, the whole tunnel is encrypted front to back. And so if it didn't come in with the right protocol on the right kind of connection, then it wouldn't have worked. But initially we just whitelisted IP addresses. Any other questions? All right, well, looks like we're going to wrap this up about 5 minutes early then. If you want to talk to me, I'm just going to be back there by the door, and that way whoever's here next can set up and get going. Let me get to my last slide real quick. If you do want to get a hold of me, the best ways to do that are by listening to me at rubyrogues.com, and James, because James is smarter than I am. You can also find me on Twitter, cmaxw. That's my phone number. If you want to hire me or connect with me in some way, I'm happy to answer phone calls. And you can email me as well. So, if you have work, you need advice on this kind of stuff, then let me know. Thanks.